Hello. Should be live here. How's it going? Happy Saturday. Been a long week. Productive. A lot of work done. Long week though. I intended to be up here and doing the stuff by 9 a.m. It is 11:18. A little bit late, but we do have the rest of the day blocked out for material science work. We're doing something kind of cool today. I have no idea if it'll work. I had a long discussion with a material scientist, and I think it should work. But generally, we're going to try to bind pufferlib to a material science simulation package to see if we can cast the problem of discovering a material with this as an interactive optimization task and get pufferlib to do that. I'll go over the details of that as we get into it a little bit more, but for now, hey, that guy, how's it going? Let me see what we can do. So, get a few things set up. If I want to do this locally or remote, probably locally, maybe. See. Yeah, probably we just do it locally, right? Maybe we don't have any issues with SSH rendering. Yes. Let's just get this set up. All I need to do is I looked a little bit about at this package ahead of time just so that we wouldn't be completely from scratch. So lamps. I believe we just cloned this thing. You want this from source. And yeah, it's just a CMake. I remember I kind of did a trial run of this. I didn't get as far as actually figuring out how to use the C API, but I did make sure there is one. Gotta get my daily RL stud fix. Out here every day making it happen. Hey, I've been gone this week because I've been doing work in person. I've been in SF. Oh wait, I'm dumb. Hang on. I didn't. Am I not in the container? Um. Right. I forgot that it's the dumb Windows thing. Yeah. Oh right. Okay. I don't have the Yeah, that's fine. Never mind. We're good then. Yeah, we're fine. This should hopefully work as is then. What did I do? Did I actually? No, I just ran CMake. How to help with super flat structures. Yeah, I don't actually have any material science background reference. I'm kind of just guessing that I'm going to be able to figure it out. I did discuss this in depth with a material scientist, though, and we think that the idea makes sense. I don't know any of the details. I do know that I probably am going to be in a better place to figure out the engineering and especially hooking it up, though, than most would be. So, there. Right. Okay, so this should build. Optionally install the executable into your system. API headers. Okay. So we can try this. And then we'll go to Puffer and we'll try to like get some basic demo. No one has tried. Oh, I didn't even realize that was you. Welcome, Yaxine. I didn't see the name on it. How's the robotics going? I wish I could have been around like more to help this past week, but it's literally I think I was doing stuff earlier in the week as well, but like Wednesday, Thursday, Friday, it was pretty much day started at 6:30 a.m. and then I didn't get back until after dark at the least. Basically have a client using Pufferlib widely, and I'm trying to get them into a spot where like they can be much more productive with the research and how they're using it. Someone just hit 3K stars. Did we hit 3K or is it rounded to 3K? Because before it was rounded to 3K. I'll post when we actually hit 3K. Oh, holy. That's freaking awesome. Material for invisibility cloaks. Honestly, like, as far as sci-fi tech goes, that's like not even my top thing at all. It's cool, but not my top thing. Post this real quick. I've got to get myself into the actual engineering mindset again because I'm doing meetings all week. Was it May? July? We have 2,000 in the Discord yet, or not quite? Why does this thing not show up? Is it 2,000 in the Discord? I'm just gonna assume it is. Now doing reward design. Oh wait, hang on. Crashing into walls. You mean the sim to reals crashing into walls? 3001. Thank you. Oh, welcome. Yeah. I replied to your DM, I believe. Come build some stuff with us. Do you just not have a sensor? Because, like, obviously, if it can't see where the walls are, right? You could do that even with just one depth sensor, though, right? Well, something's not hooked up right. It should be very easy to learn, like, to not crash into walls. So I would identify whether it's a problem in the sim, or it's a sim to real, or it's like, yeah, something screwy for sure. Like, I would understand if, okay, it's harder to hover because there are physics assumptions that aren't baked in. Not crashing into the wall should be pretty easy. Here we go. Back to real work. Lamps built. Why is this stupid bar not way? Go. Okay. All. And this gives us probably headers on global path. Maybe. Okay, so it's built. Where's the API? The API. We want this, right? They have a GUI as well. Course library.h. So if I just do here, here for me. This. So what am I doing? It should be They have sample programs anywhere? Okay, they do have. Can I just run this? Let me see if this actually runs. This can I? This has got to be test.c. It's already on the path. I probably have to link, don't I? No, actually, this does show up. So hang on, why? That's being included correctly, then why? Not working. There like extra compile flags you need? Oh, hey, Convert, and hey, welcome as well. Kim, what are you making? I am trying to figure out how this material science package works and get it bound to pufferlib. To build tests. Well, I just want to get like a standalone file that I can build in the simplest way possible. I figure I'm missing some args. They have probably in CMake, right? It's annoying that I have to like go through and find flags. Oh no, this is a gigantic file, man. Do they not just have UCC flags somewhere for how to do this? That's flags, okay. I don't see any extra link stuff. We compile this thing. Add library. Well, they have all sources. Alg source. Okay, so it links a whole bunch of stuff. And it looks to me like that's only set up with make or with CMake at the moment. So am I understanding this right? Shouldn't I be able to just build an archive where it just has everything in it already? Yeah, the problem is I just want to link in the static archive, don't I? Yeah, I shouldn't have to add to one giant. Well, I guess it depends how it's set up, right? If it compiles statically or if it's like linking in everything. Oh wait, there is a thing here, isn't there? It's got to be G++ because there's a C interface to a C++ package, I believe. I bet. Freaking CMake, man. Go to the traditional make tab. Where did I miss that? Oh. Why are we making things? I'm just trying to figure out how to get lamps to work, Bet. Material science package. I'm trying to figure out how to get, like, just a simple GCC, I guess G++ working. Clang would do it, right? Let's just compile this with Clang. Add C++ in it. One giant thing. Clang. Is it Clang++? I thought Clang just base all worked for C or C++. I thought the package just had both in it. Serial scientist. It is in the kitchen. What? Oh, where is it in the kitchen? We're currently, this is brand new. We're just trying to figure out how to get the package to even build. We have some reasonable ideas on what to do, but I don't know. There was information here. Library of C++ and executable. Choice of compiler. Okay, it is Clang plus. Bad. For some reason, I thought Clang just by default had both compilers. So GCC is fine. Build the executable and library. I shouldn't have to. I shouldn't have to rebuild lamps. I have it built. I'm not modifying the library. Yeah, I should just be able to link it, right? Wait, for creating a shared library, all the libraries that depend on must be compiled to be compatibly shared. Be the case for all libraries included with lamps. Okay. Why is this not? I'm like, something is just not clicking. I'm just not understanding something about how this package works. Oh, I should probably. I don't think I should be including source library.h, right? Yeah, it's probably that I probably need to like add the link flag and just include library.h or whatever, don't I? Yeah, it's probably something like this, right? And then you add like L lamps or something. Yeah, no. Cool. Hey Ditya, seeing you after months and you're fit right now. Honestly, I think I'm less fit at the moment. I've gotten a bunch of injuries that make it pretty hard to do all the exercise I want to do. I'm still in decent shape though. Be doing 10K tomorrow with some hills. Still deadlift well enough at least. Hang on. What? Oh, create build. Oh, okay. So there's a flag. Then you install. Hey, Major. Okay, so now you do this, I suppose. Then you can compile with GCC and L lamps. What we would want. And now it's a system package, right? Now we can do like this. I think this is right. Then we can compile with just GCC. Because I'm just writing C and we're just linking this API. I think this is how this works. Working directory. Wait, what? Shouldn't need to alter the headers. Well, lamps is the name of the package, right? Hey, Spencer. I'm just getting started on it. We're figuring out how to get the package set up and to use the C API. It's probably going to be the most difficult part, honestly, is just figuring out the basics of the package. Shouldn't be that hard to get it bound to Puffer from there and run perf tests and such. Good job on that article. You're doing really well with the promo. Had so many meetings in the last few days that at the end of one of them yesterday, I just like got up and said, "All right, out of brain cells for the time being." uh, we hit 3,000 stars officially. I don't know. Let's see. Did we pass Torturel? I don't think we did yet. It's gonna be very close. Where is it? Oh yeah, we did. Huh. Yeah, guys, we passed the meta-backed reinforcement learning library. Isn't that crazy? And actually, isn't this older than Puffer? Wait, hang on. Yeah, okay, this library is literally older than Pufferlib. It's meta-backed, and we've just passed it. Well, the thing is, if I do post this, then possibly a bunch of people will go start this. But, yeah. This is kind of crazy. You haven't passed Torch Tune or Torch Titan? I don't think those are actual, like... Aren't those Yeah, no, LLM libraries don't count, dude. Yeah, obviously, the libraries that are for the space that has tens of billions of dollars of investment, we haven't passed. That's not apples to apples. This is way closer comparison. Like, the things to consider on this space are like SB3 and such, right? Those are the bigger ones, which have like way longer time advantage. Yeah, we've passed Torch RL. That's crazy. 3K stars. Having fun with this. Accomplishment for the day. Vincent left meta. Yeah, I know. Well, but this is the thing, right? It's like you put out a thing that's backed by the big company name, but you don't actually invest in it. And like also the design of it is way ridiculously high level. It really the design doesn't make any sense for where RL is a field. Like the design of the library, it's like it would only make sense pretty much if RL were as mature as supervised learning is, right? Where you can just grab different components and make something that works roughly the way that you'd expect. And frankly, I don't even think that I will be the one to make a library for that when RL gets to that point. Maybe I will be. After all, it would be kind of sad if Puffer actually gets RL to be the stable insane field, and then somebody else just like, okay, cool, now we can build the dumb library because everything is solved. Not Puffer. But maybe I will. Even for more mature stuff, like, yeah, you can have more sort of reusable components, I suppose, but Torch RL is still too high level for my liking, even if that were the case. The best possible situation. Okay, so we have this. Let's see if this does something. Okay, so try this then. Okay, so there's no lamps library.h. Kind of what I expected. Double check it exists. Alright. Should have installed it globally, right? That's kind of what we're expecting. Yeah, it's not there. From the llama CP. I mean, that's also possible. If somebody wants to build a front end on top of Puffer, that's also kind of fine by me, right? But it's kind of difficult to do that with the way that Puffer is at the moment. It's really not designed for that. I mean, that's something I would be more open to doing the longer term, right? Is like, I guess it would be more so like the better analogy is something like Keras, I guess. Um, where if people want that type of an interface, like I'm not going to be the one to build that, but sure you can build that. I would probably do like the lower level interface, but I would actually make it so that you could build a higher level interface on top. My T guy started the live. Hey, I slept in a little bit. All right, it was a long week, a lot of work. Do I even need to build this thing from source? Hang on. You can download lamps as an executable. Then a modify or extend lamps. Can I not just do this? Maybe we can just literally get the package. You have lamps. Sure. Yeah, that's I don't know. I was supposed to build it there, I'm pretty sure. I worked with Isaac Jim and more recently a little bit with Manny Skill. The heck? Why not just install this? This works. Welcome to all the new folks here. Apt install this. That should give me access to the like that will actually get me the header files as well, right? For the API, it won't just give me like the CLI options. I just need the simplest way possible to use the C API of this material science simulation package. RL plus material science, what are you cooking, good sir? Well, pretty much the initial idea is can we can we just pretend all the atoms are agents and have them steer themselves into a configuration that produces a certain property that we want? Like the initial idea. I've discussed this with an actual material scientist who says this is not completely crackpot. So, no, I'm not implementing the alchemy paper. Is that RL? I didn't think that there was any RL with material science. I thought it was like generative model or sequence modeling. I'll go look. Which paper is it? What's the full name? Oh no, that's totally different. No, not that one. Yeah, that's completely different. Soft matter, materials, RL. That's cool. Well, I mean, we're gonna be like whatever RL is out there with material science, we should just be able to kind of crush. Like we have orders of magnitude more perf. Alpha chip. The alpha chip is actually, I think, harder than this. Ironically, I think I think material science is actually going to be much easier to solve with RL than chip placement. I could be wrong, but at the very least, the way that I like, it's a very different formulation. Control active pneumatics and other soft. Okay, see, it sounds like you actually have a background in this, unless you're just googling things. So, this is kind of the point of streaming this stuff, right? We need people who actually have some knowledge, domain specific knowledge. I have zero, right? I know how to build things. I'm a reasonably competent engineer. I know about a lot about reinforcement learning. I've built very, very high performance reinforcement learning. What can we do? So here, I will tell you the initial idea, right? So the initial idea of the thing that we want to do here is to okay, so in material science, right, when you use simulations in research, a lot of it is you kind of set up the simulation the way you think it should be, you run it, you spend a bunch of compute, you see what happens. If it's not what you want, you try something else. So instead, what we want to do is specify the outcome of what you want to see happen. Like, I want a material that has this type of heat dissipation, for instance, and I know that these are the atoms that we're going to use. This is what it's going to be made out of. I don't know how they like the arrangement, how they should be configured. Okay, we're going to have all the atoms steer themselves into the configuration that maximizes the specific property we're interested in. We're going to do that by RLing, literally just driving the atoms around. And we're going to see if we can get that property, then you'll just be able to look at the configuration of the atoms and say, ah, okay, I need to figure out how to produce a material that has this crystal structure or whatever, and then it will have this heat property I'm interested in. Genetic algorithm search. That is incredibly inefficient. Yeah, genetic algos are incredibly inefficient. Learning force fields with RL. I don't know if we're learning force fields with RL. You kind of don't have to. You're allowed to sort of break the laws of physics a little bit with how you move the atoms around, as long as the final structure has integrity, right? As long as like the final structure is stable under the physics sim, it kind of doesn't matter how you get there. I can't. Why can't I include this? I don't understand why this package is set up this way. Will the sort of said material be done step by step? Yes. Harder than so you would do it by like literally. You're assuming that you have something that you can run to check the hardness of a material. So like the atoms steer a little bit, you check the hardness. The atoms steer a little bit, you check the hardness, and then that's the reward. The difference in hardness is the reward, for instance, in that example. Structures are predict your physical properties. In colloidal self-assembly, there's a lot of effort to reverse engineer how individual units must interact, result in a specific structure. Yes, so this is absolutely punting on how do you actually get the material into this structure. But at the very least, you can know that some like a structure exists based off of this, right? What are you linking me? Inverse design of soft materials. Oh, okay, cool. So yeah, it's kind of this, except that evolution is horribly, horribly inefficient. Yeah, okay. This is the word though, inverse design. Okay, but like the difference here, right, is like genetic algorithms suck and don't actually work, and we have some of the most ludicrously optimized deep RL in existence, right? So we could potentially do something like this. Let me actually download this and save it for download button. All right, I'll just keep the tab on the other monitor. Matter is too complicated to put into a sim. Well, that's not true of all matter, right? Like, simulation is leveraged extensively in material science and in a whole bunch of other fields, right? liblamps dev. Does this work? Or did it just make this up? Yes, there is a liblamps dev. Boltzmann type configuration and training loss in memory. Wait, what? I highly doubt you need to do anything specific to the actual RL because it's material science. You, it's been my experience. You really don't need to do anything fancy. You just use our stuff. You get fast sim. You get an appropriate reward function. And it should work. The RL is very good now. Offers low level API alternative lamps. Well, okay, this is not lamps not working well. This is just me not having it installed correctly, right? Ah, okay, cool. So it actually includes this, but now it doesn't have MPI. Switch to an MPI compiler. Void value not ignored. Okay, well, it's actually doing something. Open no MPI. Science dedicated puffer. Go hard. I mean, this is my ultimate goal with puffer, right? I care about science and like making ridiculously cool sci-fi tech. That is kind of my goal for everything ultimately. It's just a lot of other applications are more obvious and more immediate, right? I think neuromorphic computing would be. I have no idea what that is. Yeah, I've never heard that word. So what did I do here? Holy, we've got at least 22 people plus everyone on X. Welcome. A fun stream. We're doing this all day. Ideally not dealing with compilation all day. We want to actually do some real material science. Wait, neuromorphic computers based on bigot. Yeah, what the heck is neuromorphic? Oh, what? Heh. Yeah, I have no idea what this is or how it works. How is this not just a GPU? Somehow more energy efficient? This is still silicon, isn't it? Alright. If somebody who actually knows what this is wants to explain it, I'd be happy to chat. Real science discovery used LLMs. Yeah, no, we're not doing. Here's the thing with LLMs for this type of stuff. It's kind of bullshit, right? Because like this is you have very simulation heavy fields, and LLMs are just like human intuition. You're not going to intuit your way into like guessing the outcome of sims or whatever, right? You have to actually run the sim. So RL is the thing that you would use to be interacting in real time or faster, way faster than real time actually, with the sim in order to edit components of it online in ways that are very unintuitive, are not captured by human intuition, but are like superhuman at optimizing. Draws inspiration from how energy efficient. No idea how that works. That would be very useful though, because we are going to have, if that actually works, because we're gonna have an energy problem pretty soon with all of the chips we're bringing online, right? I mean, realistically, like you can kind of just scale solar for quite a while, but it will be very expensive. RL Alpha Zero, yeah. Well, it's not like LLMs are dumb, but it's like people are overusing them. They don't make any sense in this context. But why is it that? Okay, they have a whole bunch of examples apparently. Can't wait to use RL to get faster physics sims to model my. So it's not necessarily that you get faster physics sims, it's that you can. The way we're doing stuff is you can write faster physics sims that are less accurate and have still get useful results because RL. Also target the system once to highlight the most important features of certain prop. Possibly. I'm gonna have to figure out how to set this up in a way that actually makes sense for the RL, right? Like the devil's in the details. Quantum. Look at see what this is. We have source files anywhere? Yeah, none of these are source files. We just have input files, right? This is like some domain specific language. And they have all these things, but like where is. Yeah, this is not example code. These are just this is like the DSL for calling the package. How? What? What is happening here? Why void value not ignore ought to be? Because it's implicit definition. I finalize, but we don't even get to that, right? It's if quantum equals infinite quantum processing power. Quantum equals nothing works yet. Okay, I mean, here is something. Get this stupid thing to work. I got this off of their example. And these are literally just like example. There's no API here. They have library.h included here. I mean, is this... Are you supposed to do this? Does this make any sense? Yeah, no, right? Because why would it make any sense? I guess that they're like targeting their local build or something, right? This is just like if you compile this from like the source. But then I don't understand how... Is there more stuff that you need to do? In models? Yeah, there's also like a dev, and it doesn't... Weird. Trying to build something that mimics a neuron. A lot of these in a modular fashion. Okay, so I guess the thing I don't understand with that, John, is like you can kind of do this in like you can emulate this just on a traditional CPU, and basically you actually have to have like a model that produces something useful, right? So I mean, possibly what you're doing is different hardware for different like more bio-inspired deep learning models, but those have to work first, right? What are you working on today? I'm trying to get material science package simulator hooked up, and I'm just having some difficulty getting everything set up correctly. For some reason, this is just like I can't get the install working yet. I mean, I guess I can just guess that maybe we need this. But I don't think you should need this for the sample script. It's also possible, I suppose. Let me just... We shouldn't have to link from there. Yeah, we have the same error. How to go beyond theory of RL into actually projects. You read my guide. It's on X. So if you go to my tab, this is a literal step-by-step guide on exactly how to get into reinforcement learning and start productively contributing to research. Like, actually, like, do this, read this, do this, read this. Congratulations. Now you're a researcher. I've tried to make it as straightforward as possible, because I get this question constantly. This is exactly what I've had other people do in Puffer that are now actually contributing to our research. Defense Department's interested. What? Yeah, I don't know how these things go together though, because like you can't come up with a new theory of computing, right, without actually being able to compute useful things. The heck? MPI is also just awful. I'm not using the Python API. Screw that. We're gonna get the C API working. Make it compute. I don't know. That's not quite what I was saying with that. Nobody gotten this? I'm confused. I expect that almost nobody uses the C API, but return value is void, but you're trying to assign it to a non-void variable. What? Their test script is wrong. Int argc handle equals. So did this change and like nobody updated it or something? It seems like we can include it. I just need like an updated C example. Test or something. Test C library. Test main.h. I don't know why they have the test in C++. Did they have a C library? Google mock. What? Oh, okay. Test library MPI, test library commands. Open. See, this is not a C API test, right? Isn't this the... No, okay, this is just a pounded .h. Wait, lamps.h? Oh yeah, thanks for the reminder, Bet. Yes, please do start the library. It does help me out a lot. Join the Discord if you want to get involved with dev. Okay, well this is just bizarre to me because they say they have a C API, but like the tests are in C++ as well. Something is screwy. Test of the C library interface. They just wrote the test in C++ for some. Alright. Test library open. I think this is the right file. They have library and then they have lamps.h included. Is it? Do I need like a different... Need this or something? Okay. As soon as I get anything working on this, it's going to be quite quick. Because, like, as soon as I have something to iterate on, I can get, like, a couple basic sims running. I should be able to get a visualizer up, hopefully. And then, like, the binding process to RL is not that hard. As soon as I get the problem set up. Fun. Lots of views on this. You actually, I can't see how many people are currently watching on X. It only tells me total views. But, hi to everyone watching over there. If anybody knows how this package works, please be my guest and, tell me why I can't get the example to run. Function's only declared... Okay, hang on. Function is only declared when the code using lamps library.h include file is compiled with D lampslib MPI. Contains a defined statement before including library.h. Related to this note? Wait, where? Where's that note? Did you see it from the LLM, or is it, like, actually in the docs or something? I didn't see that note. Like, it shouldn't even be using the MPI at all. Yeah, Spencer's post is done very well. It's good for him. He's, like, been doing great work. Can't endorse him enough. C++ specific header. Okay, lamps.h is a C++ specific header. Okay, so we don't want this. Okay, you don't want to include lamps.h. You want library.h. We don't want this. Oh, hang on. Functions like lamps return a void star handle directly. Installed version from apt. Older signature. Requires passing handle. This is an old version of Ubuntu. The third argument to set it. Okay, so it's the docs are for the new version. Okay. So you should just build... We should just build the latest thing and then figure out how to get that to run, right? And then possibly on, like, 24 or whatever, when we go to install it on our servers, we won't have to do from source. But for this thing, I do have to do from source. I mean, when he says doing construction, he means managing, like, pretty large construction operations. So, talented guy. Yeah, I know. Let me see. Okay, so we're here. We do have to do... we'll do with MPI off initially. And this should give us user local. Okay, so the hope is that this should get us the new version. -J. Okay, so does this now do anything? Undefined reference. Okay, so we still need MMPI pick or whatever. Undefined reference. Okay, so now we have this in here, right? So now we have library.h. It's not that big. Kind of has all our functions. Open. So here's lamps MPI finalized. So this should definitely be here, right? If we're including this, it should definitely be. So let's do. Okay. Yes. I don't know if this has done anything, but it actually does run. So, yay, right? Opens, prints version, runs. Cool. So what happened was the system package for Ubuntu was outdated, and the library script was targeting the latest version. So now we actually should be able to do something with this. Why did all the viewers on Twitch just die out instantly? Did the Twitch stream crash? Or is it botted? No, it's still here. That's weird. It's weird because YouTube doesn't do that. The Twitch one's like, yeah, the Twitch one's probably bots. Okay. Um, this works. Now we actually get to build Sims. I'm gonna grab a cup of coffee real quick, and we are going to get to do the real work. Right back. Let me forget to unmute my mic. Okay. Let's see the CAPI examples, right? Creating or deleting lamps, executing commands. Lamps command string. There are multiple ways to drive a simulation. All encode and have lamps act on a series of input file commands that are either read from a file or passed as strings. That's kind of slow. Okay. I mean, this is the interface that we have, so cool. Lamps get num atoms, get thermo. What sim environment are you building? This is a hook into the lamps material science package for atomic level simulation. So we're trying to hook into a material science package, set up some basic simulation, and see how we can change some stuff. Get thermo. Gather and gather option. It seems like the CAPI is kind of well, no, this is kind of okay, isn't it? It seems like it's very much C++ and the CAPI is done after. It's kind of like, it's kind of janky for C. Atom-based entity for a subset of atoms. Collect and gather bonds. Just mirrors, this kind of almost look like Python, right? Like they do everything through strings for some reason. Styles. Just get an atom, I suppose, right? Like, actually, this is an old enough package that the LM should actually be able to like at least get me basic setup. Okay, so it's not that bad if I think of it as the commands are well documented and the CAPI kind of just runs the commands. Kind of crazy that it does everything through these strings. I really wouldn't expect that. Setting up the simulation with velocity and run. Did it really do everything through string commands? Crazy gross. Secret funny. Cooling. Atom positions can be modified directly via the pointer from extract. That's what we want. Hang on. This is here. Okay, let's see what they gave, what this gives me. So they kept this, and then it added this blob here. First of all, let's see if this runs. Okay. So, this actually looks good. Position after manual move. Okay, so units. Oh, I don't know what this does. Dimension 3, boundary, atomic style, atomic. Pair style, dummy pair style for no interaction. Region box block. Create box. Okay. Now load a single atom at a specific position. Create atoms, one single. Set up for running simulations. Time step and integrator. Time step 005. All and V. Extract. Print the initial position. So extract position 00010. Run a minimal command to minimal simulation initialize. Move the atom, directly modify the positions array. Re-extract the pointer for safety after commands. Okay, so you can directly just change this. That's fine. Position after move. Hang on. Initial position. Position after manual move. After first run with velocity. Have moved. Wait. This re-extract and print position after run. Demonstrate running a simulation. Set the velocity and run. Atom will move based on velocity during the run. We re-extract and print after the run. Moved by v times dt times steps 0.05 in x. Position after first run with velocity. It doesn't look like it's moved, right? And then after this, so it's almost there, except it doesn't seem like it's moved. This code runs, but the velocity calcs don't seem to be working. Your similar one ideal gas particle. Yeah, so this is a trivial simulation, John. Pretty much all I want to do initially is can we just steer around an atom? So like if I can get this to work where you can set velocities and it behaves as expected, then what I can do is I can take this code, I can put it into an RL simulator, right? And I can hook up the actions to be the velocity or whatever, and see if we can steer around the atom. And if we can do that, then we're actually like we have a basic setup for doing RL plus material science. Having multiple atoms from an RL perspective, like that's easy. Obviously, the simulator's going to get slower and more complicated. We can do stuff from here. Granular control, like modified velocities and positions. Yes, that is the goal. No, no, no. We're not. We're going to actually do like micro. Like the more stuff that we give the RL, the better. Because otherwise these sims are very slow. So I want the RL to have as much control over the sim as possible. Because otherwise it's going to need tons of data to learn. What? Just gave me new code, I guess. Yeah, so this didn't do anything, right? I think it just gave me the exact same code back. Thing. Well, let's see if I can figure it out. You set the green screen to a gym. Darkness is very irritating. What, you want me to green screen myself into my gym? So, like, even though I'm not physically at my gym? What do you mean the darkness is irritating? I work closely with soft matter experimentalists on control problems, and therefore the action space is exposed macro variables. This way they can use RL to control their experiments. So, John, typically with RL, because here's the thing. Your simulations are slow, right? So you want to collect as much interaction data as possible for the RL because RL needs a huge amount of data. Right? Like RL really likes your simulator to be fast. When your simulator is slow, the best thing you can do is kind of like try to parameterize it more heavily so at least the RL is getting like pretty constant feedback on very small changes. The home gym. Go outside, take a picture of my garage gym and put myself in there. I will consider this. Yeah, so why does this not run velocity? Run 10. Am I crazy here, or is this just not moving? And so moving it works, but then running the sim doesn't work. See? Wait, re-extract, hang on. Position after manual move, and position after first run with velocity. Does anybody understand what's going on here? With NVE, hairstyle 0 was set without no coef. Flex a pair coef to fully initialize the pair interaction. 0 computes no. Okay. Hairstyle 0. Error pair coefs are not yet set. Okay. Oh wait, am I in the right? Yeah, I am in the right spot. Add no coef. Avoid needing pair coef. Anything wrong here? Its dimensions, atomic style. Seems fine, isn't it? What is lamps? Why are you messing with it? What's the end goal? Lamps is a material simulation package. It's used in material science research. I am messing with it in order to see if we can use reinforcement learning to aid in the discovery, essentially, and testing of new materials in simulation. And the current goal is to be able to steer around an atom and hook it up to Pufferlib, so Pufferlib can steer around an atom in a package, and then from there, I will talk more to the material scientist I know on like how we should set up an actually useful sim. Once we have benchmarks, make sure it's actually fast enough to be useful, and stuff like this. Manually steer it with what? With RL. It doesn't have to physically make sense. Right? If I can steer the atoms into a configuration that produces a heat dissipation property or like a structural integrity or whatever that we want, you can look at the final configuration and say, ah, this is the material I have to make. Well, you don't necessarily need atomic force micro. Like the material scientist might just look at it and go, oh, yeah, that's a totally standard crystal lattice. I know how to make that. Right? Or like, I don't quite know how to make that, but I have some reasonable ideas. And like, hey, this is a heck of a lot better than me having to guess not only how to make the thing, but like what the structure should even be. Material science kind of kicks ass. Hairstyle 0, 1. No coef. Oh, this is actually kind of cool that this is really good that they've done this. I saw it was trying to go to the source code to like look at the details. Good job to the X team. But unfortunately, it kind of just spits out the same thing as far as I can tell. Oh no, hang on. It did add a line. It added a line here. I don't know why it like just gave me the whole additional script and just spit out. Ah, here we are. See what this is. Task time breakdown. Loop time. Time steps per second is 389,000. Okay. Pair neighbors. Where are my prints? Position after manual move. Second run. Okay, hang on. Position 505. Perfect. Perfect. We have it working. Good job. Good job, Grok. So now, who's ready for Material Science Sim plus RL, right? The one slightly obnoxious thing is... The one very slightly obnoxious thing is my editor. I don't have Super Maven. I would really like my my autocomplete to work. Well, I can handle that just by doing the dev on the remote server, and then I'll just pull it down. Yeah, let's just do it that way. It'll be easier. You're making an end from scratch now using... Well, it's not exactly from scratch using lamps, right? I mean, lamps is doing a lot of the heavy work here, at least for the initial bit, till I understand this more. We might end up just doing our own stuff. This is like a very initial pilot project, right? Like, this is one of many things I do where if it shows promise quickly, I will go heavy into it, and if not, then I will wait until Puffer gets to be a little bigger and try again. Okay, this actually runs already, which is cool. That's, and then there's one other thing we gotta do, right? Yeah, I know that's normal. I just wanted to see if it built bad. We have to get remote rent. Actually, yeah, I should just start adding freaking tasks for contributors, because there are actually... Pufferlib's getting big enough that we have people on the engineering side who would actually be just, like, happy to help us fix random crap. And, I mean, these are things that actually take me quite a bit of time to figure out for future viewers. Yeah, fair enough. Thank you for the annotations, Bet. Heck are we? That's not supposed to be there. Yeah, why is there a template.py? Okay, so... I want to make sure this runs, and then we can get it to my local, and we will be able to do material science things from there. Hello from YouTube. Hey, Weston. Long time no see. We're doing science today. Okay, so this is fine. It runs. Um, we are set. Let my figure this out. No PowerShell. Somehow the world seems intent on keeping me from doing RL and just chilling. Yeah, that's some bullshit, man. We're doing cool material science here. Well, not super cool yet. I think it'll be pretty cool in a couple of hours. At the moment, we're just setting up very initial bindings. Go for variables. That it's kind of hard bet at like you have to be like legally an adult who can do things and make your own choices first. Right. I forgot about this. Detected coup diversion. Eh, just do like this. There, yeah. A totally different conversation, Magnus. You don't have context for this. Anyways. Oops. What I do here? On the GPU, is it not? Yeah, Magna. It's My local desktop is screwy. It's just it's old and I haven't had time to reinstall everything. Don't worry about it. I'm doing this so that we can get a visualizer built in. We're not actually gonna do most of the like training and stuff on here. It'll be for the remote machine. Go to Micro Center. Yeah, don't mess up building it. Okay, so this runs. And this is not the material science environment, right? This is just a template that I've renamed stuff on. So this is the little template environment. We're going to actually go put the material science code into the template. Fix remote rendering is on the list of things. I don't think it's a puffer thing necessarily, but I think it's like a container thing or like an exporting thing. I gotta figure out how to just like put a board somewhere. Like, hey, things we need people to do. Just take this stuff out. Uh, this here, top. GitHub could open it. Yeah, I don't want to use GitHub issues for this because I can't just say like, oh yeah, fix open issues because other people raise dumb issues. I need to have like, yeah, these are the things that we need done. I might do like a Discord channel or something. We'll see. I think GitHub technically has a board for these. I could make like a board. I hate having boards. But here we have a goal position, a very basic environment, like, but it's basic environment with atoms. So I guess it's cool or whatever. Norm 3. Yeah. Vec 3. Oh, because it's using the just... Okay, I see. Yeah, this is fine. We can do this. Instead of having a float, we'll just make this vec 3 goal, right? X, Y. Good. Now we do if dist norm 3. Fix the index for VX for VZ. What I do? Wait, index for VZ and third action. What? Oh, thank you. Okay, I think I know how we're gonna do this, right? Like, set the velocity. I get the Raylib cheat sheet up. The idea is going to be we're going to make like a very basic 3D steering environment, and then we're going to make sure this works, and then we're going to swap in the real, the atomic simulation package. Okay. This is good. Added this. Sub 3. If distance is less than 0.01, get rid of this, right? And rewards. The tick. Python syntax. What happens when you code multiple languages? You screw stuff up. Reset. Words, terms. We gotta do compute observations and reset, right? We'll just do like void compute observations. And doesn't have to be super complicated. Thing like this. X y. Okay, so just basic delta obs. Okay. The reset. Log everything. 1. Nothing. Turn. Otherwise, velocity, distance, this. Okay, something like this, roughly, right? We do have to do a basic 3D renderer, but it should be quite easy. Just gonna go grab our drone renderer real quick and hack it a little bit. Think it's in here? Not. You render like this, right? Make. Okay, and that's M script and bullshit. Okay, there's a lot of annoying crap in here. We'll do it one at a time. I probably need like a good chunk of this, but not a ton, right? Like, I just do this, put this thing in here, 30 FPS, then window. You also need a camera, don't you? Hang on, that was a little bit over ambitious, right? Gotta do this. Do this, yeah. Width, height. Just do like this, right? Why did that indent so much? Oh, geez. Okay. Tabs. So, this goes away. State camera position. And I think we just take this crap as is, right? Do like this. Cool. Happy with this. Alright, so this is fine. And now I just need to go get the 3D args from here. Say. Yeah, so a lot of stuff here. Honestly, we should just copy the drone thing entirely and just delete stuff. It'll be easier to just hack this than it will be to just make a new one. I haven't done this, like, it's been a good couple of weeks since I looked at this. Except not like this, hang on. This. Here. This. This. Camera controls. Okay, now we have to do the particle, which is literally just to draw a sphere. It's kind of funny how similar this is going to wind up being to the drone environment, right? Like, you can steer drones in space, or you can steer atoms in space. The RL doesn't care what you do. Drones are just atoms. Wait, why are you indenting manually? Because my editor screwed up, Tiger. And I don't want to take, like, a bunch of time on stream to fix it, so I'm just, like, typing quickly. Dead. This is not the normal stream setup. This is, like, the jank stream setup, alright? This is me in California with, like, a super old desktop that should probably just be overheating randomly. Ion? What do you mean, Clion? That is our resident advertiser. So I do appreciate, yes, Bet, do. If you're new around here, do star the repository. It helps me out tremendously. All this work is free and open source. We have dozens of people that are now in the open source community who came in with no RL experience or helping us to push the research forward. This is like a space where, with all the stuff we've done, this was a very inaccessible area of research before, but now it is very, very accessible, and the progress is very rapid. It's quite exciting. You also move while in insert mode. Do I? I don't know. This is the thing we needed, right? Which is basic, super, super basic. Something like this, ish. Ish. So the plan here, right? The plan here is probably should have just started with the drone environment, honestly. Like, I'm realizing it's basically the exact same thing. It's like steering in 3D space, which basically just drones. That funny material science is just drones. Um, but yeah, I should have started with that. But anyways, we're gonna get ourselves a basic minimal environment setup here for steering around atoms. Then I'm gonna include the lamp stuff, and we're gonna actually hook it into the real dynamics. The goal, at least. Vec 3 not in here. Is it like Ray Math? Math.h? It's not math.h. What? Oh, they have their own Vec 3, lol. Yes, the client needs to go up top. This. Size not refer. F. What I do? What I do? Not right. Camera controls. Null point. Ah. Okay, well that was something for a second. And the actions are wrong, that's fine. Reaction. Do, like, no. I have come to say I cheer for you, my friend Arin here. Hey Arin, we're doing material science today. Welcome back. How are? Let's see. I do? Oh yeah, observations. Float star. Glad to be here. Welcome. Okay, perfect. So, atom in a box. Say hello to our atom. What are you trying to do now? Well, I have a test script for lamps, the common material science simulation package that works for like moving an atom around. Uh, I'm I have pufferlib, which is really good at reinforcement learning, and now I'm putting together a test environment in which I'm going to include lamps, and I'm going to use reinforcement learning to steer atoms around into different configurations, and then test what properties these materials have. And I'm going to hopefully get this to be useful in actual material science research. What can I provide with you? Your background was in something related to this, wasn't it? I'm trying to remember, what was your background in? It was like something hard science, right? Chemistry. Very cool. So, I mean, yes, related. Atoms are atoms. How does the main method in the .c file work? Building custom M's, I put all render controls in C render method. Because doing that in the .c would not work. All render controls. Building custom. So, the .c file is not used when you run from Python. Okay? So you only include the header file when you are running from Python. The .c file is just meant to be a test file. So you can run your environment in C without having to compile from Python. So anything that you only want to be in that test and not available from Python goes there. So for instance, if you want to be able to like control the agent with the keyboard, usually you want to just do that in the C test because the neural net's going to control the agent otherwise. But sometimes you might want camera controls in the .h file so that at least you can like play around with the camera when you're running from Python. I don't know if that answers your question at all. What the heck is wrong with this? No? I'm trying to think what the heck this is. How the heck did I mess this up? Oh wait, is this supposed to not be? That specifies double. Argument has type int. Ah, dummy. I see the error. We're good. Easy gotcha. Alright. Hey, look at that. We have an atom. Moves around. Yay. Thank you. I think it's a very nice atom. Okay, so here's your goal, here's your atom. New what is atom meme? Boxes. I saw a colleague of mine say, "Hey, look, this is mostly your fault if you forgot to cite the paper." But like, honestly, if your reviewer doesn't know what atom is, that's like such just a colossal screw up. Um, that's like such just a massive colossal screw up in having that person review that kind of trumps everything else in my mind. Three. Yes. And sure, we just see if we can train. Hello, welcome, Kitting. Okay, so material scientist linked me the three body problem. Conduct some thermal conductivities. Liquid with body potential. Error? What I error? Outside. Ending.c. Yeah, we don't need. Yes, this is not giving us back any logs for some reason. Huh. For log n. This, shouldn't this work? This should work. Why is it that this is not showing up? What the hell? Four. Right? On log score, log n, right? Log n. Reset. This not, correct to me. I messed it up. Not, backlog. What did I screw up with this? I get this quite often as well. It's sort of silly. Well, hang on. This doesn't work. This doesn't do anything, though. On. This be... Required keyword arg size. Well, that's not true, right? Oh, I know what's going on. Never mind, no I don't. What? Required keyword arg size. Yeah, log interval's not getting used. Take you 3 minutes. You know, you're probably right. I should just do that. Hey, Larry. Better. And just run the other thing, right? See? That's the kernel. Be like build C. Yeah, there you go. Okay, so required argument is size. Uh, no, there is no size. That's what's weird. You don't need that param. Okay, there. That runs, maybe. Okay. Double free? I'll find it, don't worry. Weird. Why is it that you never get the here? Here's the issue. Okay, so now I see the prints on the goal there. Was getting the goal, but wasn't contributing to score, which is weird. Oh, you know what it is? I know what it is. Know what it is. My own thing. Hang on. Float 32. Dummy. Train. All will be well with the world. Not ban this bot real quick. Yep, so that works now. Okay, we are successfully steering the atom. It appears. For the most part. See? Steer the atom, yes? Very, very simple. Okay, so now what we have to do is we have to get the lamp's dynamics into this thing. Let me at least commit this. Okay. So, here's the lamps test, right? This is not that bad. Need an init, don't we? Basic setup crap, right? Any limit on observation action spaces for environment? What do you mean any limit? You can do discrete, multi-discrete, and continuous boxes. Typically, you'd like to have either low dimensional continuous, singular discrete with like not a crazy dimension to it, or like a multi-discrete with not too many components, each of which is not a crazy dimension. Oh yeah, so technically we do support structured spaces with our emulated API. So for third-party environments and stuff we do. In our native environments we advise against it because like Hopper's just really really fast and we try to avoid doing anything to make it not fast. We do technically have actually to be fair, we have the best structured spaces support of anyone, but we don't use we don't use it because even though we have the best structured space support, it's still way better to just not do that and have the speed. Yeah. Okay, so here are your velocities on the sim. Okay, we run our sim. Do this, right? We do not need to reset our position. But we do need... Okay. And this is no longer needed. Something like this. Probably need to fix up some stuff, but yeah, whatever, right? Oh yeah, we need handle. This. Variable version. Hey, Georgie. How's it going? Doing material science. Hopefully I have time to fix minor example of pufferlib as a whole on Windows. If you want to get that working, go ahead. I think our vectorization is probably going to totally mess up on Windows. You might literally have to use serial. Unless you use WSL, in which case it should work. Kinda a year. What? Distance. Oh, I'm silly. Yeah, I got rid of distance. Let me go get that back. Silly. And I have to do the lamps link thing, don't I? Yeah, dash L lamps. Cannot find L lamps. Play. Find L lamps. Really? What is wrong with this? What is going on here? Oh, dummy. Huh. Very good. Okay, so we have to actually get it to move, but we have a basic thing. It's running through lamps. We have a puffer end. This is very close. This is very close to being what we need. Fun. I gotta do the article soon, the new article. Alright. I will, missing an M? Yes, exactly. Very silly. Alright, folks, give me like a couple minutes. I gotta walk around and, clear my mind, take a quick take two, grab a bagel, whatever. And we will actually see if we can get the RL to steer the atoms using the dynamics of this package. So it's a trivial example for now, but as soon as we put in like 2 or more atoms, it becomes non-trivial. So, be right back. Welcome. This has just been the short intermission. I've only been live for what, few hours? Not even. Yeah, like 3 hours. I'm tired though. Been a long week. Probably put in like close to 50 hours in the last 3 days. At least if you include all the travel time. Yeah, I just did a little meet and greet. I think it's kind of funny when people like reply to me, "Oh, can we meet up? Ha ha ha! You won't see this." I was like, "Yeah, sure." All right. So motivation is hard to come by with programming. Not really. Programming is just, at least I find, it's something that does not work when you're just tired and burnt. So instead, I don't force myself to. I kind of like work until I'm like just dropping productivity. Go do other stuff for a bit, right? Tomorrow I will be going for a good run and chilling for most of the day. Wouldn't even say I'm super hyper motivated. Well, I guess I kind of am. There are definitely people who are like way more fixated on stuff than I am, though. Try not to say stupid founder shit. You know, one of the things that's been really funny in the last few days is I talked to people in SF working on various companies, right? And SF is such a bubble. It's basically like LLMs are the only AI that exists, and the only type of valid company is a GPT wrapper. And then it's like, hey, there's this whole other branch of AI that is going to solve problems you can't possibly hope to touch with anything you're doing, right? And it's just like, what? Holy hell, this is cool. Late to the stream. How are you implementing RL in material science? Um, we have this hooked up to lamps, and the goal is to literally steer atoms into place in order to produce a specific high-level property that we want. So it's basically like, what if instead of steering drones, we steer atoms? If this works, I'm gonna post that. For all the people that give me shit about doing stuff with drones, it's like, yeah, the RL doesn't care if it's steering drones or steering atoms. Kind of the cool thing with RL. It's like the same algorithm, same everything. Okay, so why is this not steering is the question, right? Oh, I know why. Run 10, time step 005. So it's actually got to be. Oh yeah, look at this. You're steering the atom, running through lamps. Problem is that this needs to not print stuff. Grok knows how to do that. Good. This is good. So, Always assumed RL would be the bigger of the MLs, just for robotics and self-driving planes, boats. Yeah, so the thing is, it should be, but it, there was. It's a field in which there's an like like a just inexplicable amount of incompetence. Like, go look at what we do in Puffer, and then go look at SB3 and compare, and you'll understand why it didn't get big, and why it actually still is going to get big. And you convert calcium acetate into acetone with it. That would be. I don't know if this does that. If this does chemical reactions. I don't know. I'll have to ask my material scientist friend if this is like accurate enough to actually simulate reactions and such. I mainly just use Grok. I use LLMs in the way you see me using them here, which is like new package, spotty documentation. How do I use it? I'm not really using it to code stuff. I'm really using it as docs more than anything. Okay, lovely. Done. What is it? Setup.py. Eval. Don't want to load this up. Happened. Undefined symbol lamps MPI finalized. Really? Well, I guess I haven't run through this, right? Yeah, hang on. I have to link the library. It's not that hard. I just need this, and I need to go to setup.py. Then You have to use Jax, FF, or similar. Okay, so it does support it, but with plugins, I guess. See how this has done this? The excluders and then extra args. That makes sense. Okay, I didn't realize there was an includers. Oh, of course there is. Yeah, that makes total sense. Being dumb. Okay, so now hopefully we can compile this. Should be as simple as this, maybe? Oh, it's not gonna like me opening 4,000 lamps, right? Um, thought it was supposed to be, like, decently fast. Try some other stuff here. Make it 10x faster. One. See what this does. Okay, it's multi-processing it. Okay, so I think we need to change basic baselines here, right? Okay. That actually gives us 13,000 steps per second. 20% env time. 16 of these. 8, 4. Okay. something 1.8 or this. Total agents. Wilson's like, really? Oh, because it's... No, this should work, shouldn't it? No, because vec num ems is going to be different. Now we're actually bottlenecked here. On the bright side, it looks like we've learned the thing. Do like... It is a very easy problem, I suppose. Then, here we have reinforcement learning, steering an atom to a target, running through a real material science simulation package. Now, it is an absolutely trivial example, but this is the basis for pretty much everything here. I'm actually kind of surprised this learns everything in 250,000 steps. All right. So, a few things to do from here. First of all, commit. All right. Next stuff to do. This has got to be multi-agent. So let's make this multi-agent. Let's get some more molecules in here. Let's see what happens. Function object has what? You use... Bet you forgot to call a function. You did like step.info instead of step open close.info. Are you planning to introduce SIMD? I believe that can double the SPS, at least double. So there are a couple environments where, yes, we need to do more low-level optimization. Um, if you do SIMD to breakout, for instance, you're not going to do any improvement because the env is already like 50 million steps per second. So you're never going to ever be able to saturate the GPU anyways. So literally all you're doing is going to make the code more complicated to add SIMD for literally like for no benefit. Now for stuff like GPU drive, where it's actually a decent chunk of the time is simulating the env, I guess not GPU drive anymore since we ported it, just buffer drive. Yes, you know, SIMD would help and we should actually bother to do that. This one here that you're looking at, there's kind of no point to doing SIMD. Because all the expensive calls are going to be into lamps, which is already doing that, right? The expensive thing is going to be the force calculation more than anything. It's force and whatever the hell other things it does. I don't know. Atomic thingies. Also, it's reset atom. Because I. What are you doing exactly, please? So this is material science plus reinforcement. I developed Pufferlib. Pufferlib is the fastest reinforcement learning library out there and also has some nice algorithmic improvements to it. We have very, very good reinforcement learning. LAMPS is a well-known material science package for doing atomic simulations. And I'm currently building an environment using LAMPS for steering atoms around using reinforcement learning in order to produce material properties that you want. So the goal here is to advance material science research by allowing the sims to be interactively optimized via reinforcement learning. Thanks for the demo. Catch you next week. Thank you. Walking robot, probably not happening soon. Reaching robot or drones, more likely. Humanoid physics is kind of a pain. We can do a lot of other good stuff, though. I don't know, maybe we could do reasonable humanoid stuff if I just, like, throw away all the heavy packages and just go down to, like, warp or whatever. Or physics. I'll bet in this case it's only really useful for the slow environments, right? So this distance thing is a little sketchy. I think what we're gonna do is let's do like vec3. Row 1. And something like this maybe. Like stick this for loop. Now we have the atom position like this. Okay, and then we do. We're gonna flip the condition. New. Okay, and now we do reset atom and x. Something like this, right? This becomes I. Yeah, this is fine. This cannot get a return on it. This. If 1 new. No SIMD, but when I look at EMS, the data can align perfectly, and there's enough loops that can benefit. I agree with the breakout. What EMS are you looking at, Shadow? So this would only apply to the EMS for which there is some substantial portion of the time that is actually spent on the env, right? So I think that most of our training at the moment can get somewhere between 2 and 5 million steps per second per GPU. So if the env is faster than that, right, there's not really any real benefit. And I like technically, yes, it does help a bit below that because you don't have to use so many cores and such. I think that really the ones that we care about that a lot would be like probably the driving env is the main one right now. But like a lot of the overhead in the driving env, it's not even from computing the env, it's from the data transfer from the observations being too big. I'd love to have some basic SIMD examples though. Like I've never done that, frankly. I know what SIMD is, obviously, but I've never done it. I've just never had to do that level of optimization for these. Chess probably as well, but bet you're kind of trolling on speed at the moment is my guess anyways. It should be able to be quite a bit faster as is. I'll look at it. Where's the material science? This is material, like, do you see this? Alright, this is lamps. Lamps the material science sim. We're working on steering atoms with reinforcement learning. Steering atoms to become useful materials. That sounds fun to me. Don't you think? Ah, okay. Materialism is bad. Well, that's because, I guess you went to communist school. Material goods are generally useful and nice to have. They're not the entire point of life. Dogmas are generally stupid. Bro, what the fuck? What? Isn't materialism bad, a communist thing? Sweet pufferfish, thank you. Definitely a hippie thing. Have some bad philosophy. Exactly, yeah. Alright. Get lamps. Uh that good, I think. We need this. Alright, like this. Something like handled. Unsequenced. Ah, yes, this is fine. Where can I find your Twitch and YouTube? I'm at Neural MMO on YouTube, and my Twitch is the same as X, J Suarez 5341. I'm streaming. I should be live on all three unless something is broken. Articles are on X. Everything VODs are on YouTube, which is best for latency. Thanks for linking that. What time is it? It's only like 3 something and I'm exhausted. Ugh, long week. We gotta get at least a couple good more hours of dev out of me for this, right? Like to at least have some basic like 2 atom system or whatever, or few atom system where the atoms fly around and do something interesting. Dueling atoms. Alright, why don't these things move around? Oh, I know. Moving? When we moving, huh? Be moving? Okay, so here's your velocity. Those were tiny numbers, right? Okay. This is now a reasonable velocity, right? Why you not move, huh? Not move. Not move because... Eh. No, this should be moving a lot, though. Yeah, it's randomly sampled bet. It should be vibrating, though. It is moving, is it? No, it's jumping around. That's resetting. Not moving. Oh, I know what's wrong. Wrong. We're good, man. I know what it is. 100% have it. Just weren't rendering it right. 100% works. There we go. No, I was using this env pause. This thing doesn't exist. There. Okay. Let's make sure it still trains. What is the quickest thing to train? Pong should take 3 to 10 seconds depending on your hardware. It'll get faster, bet. This is like an unbatched molecular sim. 10 seconds then. Yeah. Pong should be decent enough. Okay, yeah, this doesn't friggin' train though anymore, so that's a problem. How'd this happen? It just ready to run somewhere in the Docker container? Yeah, it's on the Puffer AI docs. I don't think I have this command set up locally, but puffer train, puffer pong. Yeah, well, actually I do. Train device, CPU. Okay, so this is like the worst possible. Yeah, okay, so this is a whole minute on Pong because this is like 20x slower than it should be. But if you do that, you'll train it. Check the docs on puffer.ai. If you get stuck, ask Bet, who's right here, or ask in the Discord. There is a Docker. There's a UV setup as well. You can pick whichever you want. I use the Docker for everything when I can. Just easier. Hang on, this is different. I'm dumb. Yeah, when you get the Docker running, everything should just kind of work. Docker good. Alright, so here you go. This is our material science sim. Now with loops for agents or whatever. And if I run puffer eval in a second here, you should see it. I'll have to get the second atom in. Here's the atom. Up. Some atoms is 2. Atoms. Here's the 2 atoms. Only one of them moves. Fix that. Puffer get repo is same as puffer directory and container. Oh, yeah, you gotta get pull from the container, Larry. It's a pre-built image. So if you want the latest puffer, you just get pull. Not building the container from scratch for you, right? It's way faster to the image to download. It's not in like there's gonna be stuff missing, but it's the version of the container that like the pufferlib version there is 3.0 when we shipped it, right? Doesn't have all like the latest source changes. I do reserve the right to break from source as well, so be warned. Keep our package stable. But you're trying to sort out here with these atoms, not much yet. We're just trying to steer them around initially. But like it's not that much of a change, right? Once we have the basics working, you throw a bunch of atoms in, you evaluate some property on them, you use that as the reward, and then they steer themselves around into a configuration. It's the idea. Okay, so this works, right? Very good. I did a lot of atomic physics. You know, the most useful thing in Pufferlib at the moment is having more people who have experience in other fields, especially in like hard science and simulation heavy areas of industry. Get a couple of those people learning just a little bit of RL, enough RL to be dangerous. We power all sorts of scientific innovation with this stuff, right? We literally have magic sci-fi tech for superhuman optimization on crazy quantities of data for like fiddly unintuitive processes. So we should be able to kind of rewrite a whole bunch of reality with that. It's probably the most crackpot way I could have phrased it, but it's true. Oops. That works. Cool. SPS went up. Okay, so are they both steering or is only one of them steering? There are only two of them moving on there. Funny post. I agree, Bet. Okay, let's see what this does for us. Hopefully something reasonable. Pretty noisy. Again, this is a very small scale thing. This looks like. Oh, the env is actually fast now. Yeah, it's not bad. Yeah, not bad. Okay. Atoms. Lovely. See, very fast. course, once we start actually simulating forces, it's going to have to do some work. Yeah, for now, though. It's still 4% like this. Okay, so n of num m's can go to 8. 32, right? Times 8 is 10. Eh, fix this. Better. The issue. Very easy problem. Learn instantly. Did I not get everything? Mess something up. Let me look. Well, the policy is not good, so it's not just a logging issue. Hi, Spencer. In plus plus and a reset. I don't see it in here, do I? There. Well, this doesn't help. Yes, you're right. What's this? Like, what's wrong with this, though? Wrong with this? Compilation. This is fine. Yeah, I don't know what I messed up here. It works with one atom, right? I have like a hard-coded 0 somewhere that I'm not seeing. C1. Thought I got them all. Okay, let's just go back a little bit. Uh, yeah, so like this insta solves, right? Well, so does this. Okay, so it is some janky hyper thing. Oh, I see what's wrong. Okay. Something, right? Okay, so this works now again. Oh yeah, there we go, right? Here are the atoms. The question is what happens when they have force interactions. Probably gonna want like 8 or like 4 by 32 instead. That's still fast. Bad. Eh, it has some fun view numbers on it. Holy. Suppose we still have quite a few people on X. Chat's always less active there, so I never know how many there are. Okay, this doesn't seem to work super well, right? Doesn't work well. Funny that that messes it up, though, isn't it? Weird how that makes a big difference, huh? Wonder if there is actually some weird thread safety shenanigans going on. There's no reason this should happen. Oh, you know what it is? No, I know what it is. Hang on. Patients. I just didn't handle this correctly. This will be so much better. Getting tired, and I just want to like get this basic thing, this system done today. I think if we have this with the force interaction, it'd be a good thing to have done. Oh yeah, there you go. Instantaneous learning. Yes, learning. There we go. Here is your policy. Very good. Alright, where is my result? LJ params. This. Probably just this line, isn't it? I have an interesting question. In my simulation, there's a spawn-related bug that appears none of the time, and I'm solve the bug because it comes with a low-level engine. Can't access this, detect that bug. And I end the episode if it appears. How do you annotate it? Truncation or termination? So literally, pufferlib does not distinguish between those two things. You're good for meeting Monday at 9 a.m. PST. I am. You should DM me what meeting this is, because I forget what the heck this is. One of the funniest things to me is how everybody sends me their resumes. Like, they don't send me their resume asking for a job. They send me their resumes asking to contribute to open source. I don't need your resume. I need your code. Like, you just show up and start writing code. That's all you do. Pretty simple, right? People like always expect some hierarchy or bullshit. What exactly are numem's variables? I see no change. Is it for parallel or something? Hang on, Spencer. Headache as well. Oh, okay, yeah, that's good. Yeah, send me the invite and I'll be good. Yeah, I literally never bothered implementing that shadow. Like, I could. Never bothered. Oh yeah, Eduardo's question. So, in this sim here, use this as an example. This is the number of cores I'm using to run. On each core, this is the number of environments I'm running on that each core. And then this is the number of atoms I'm running per each of those environments. So the total number of agents is equal to this number times this number times this number. Is having a seizure. Lovely. Catch you tomorrow. Sunday's my day off, but I will catch you Monday. Guys gotta rest. Right, this is what I was doing. So I mean, technically, we could literally just do this and be done. If this works, we can do a little bit more. Might take a few minutes break to like go get a Tylenol and walk around a bit. You'll see. Come back for another hour or so before dinner. Play. Sunday is the Church of the Puffer Day. Yeah, you can come to the services. Puffer cult. Why do these not behave any differently? They're probably like too far apart, right? What? Okay. Proc is supposed to be able to do all physics problems. That's some bullshit. What is the tail lamps coefficients are? Actually, you know what I should do? I should just go grab yeah, I'm gonna go take a few minutes. I'm gonna grab my Tylenol. I'm gonna do a couple things before I like, cause I'm just gonna get worse. So let me take my break now, and I'll be right back, and we'll figure out if we can get the atoms to interact correctly with each other today. So you'll actually see them like curve when they get near each other and stuff. I'll be back. Okay. You know, there have been 0 materials discovered so far today. Gotta discover some materials. Can't be that hard, right? Alright, I was looking for... I think the atoms are just not close enough or something, right? Okay, so it is femtoseconds, I suppose. Just ask Grok. It's... Oops. See what... Is it angstroms? Probably angstroms, right? How big is an atom in angstrom? Like... Size of... 0.5 to 1 angstrom. Okay, so they're all about the same size, obvious, right? They aren't. Gold's like 1.35. Probably an angstrom, no? I just gave up. Nah, he didn't give up. He just moved on to the next thing until I go, like, flame him a bunch and he feels bad that he didn't get it to work. Then he'll come back and do it. What does Kyle know? I mean, I do think it's actually kind of reasonable to get the sim to real working quite quickly. The problem with him is he's also doing new form factor. Like, the drone thing will not be that hard. Just, like, get it to fly around. At least I wouldn't think it will be. Why are some of these stationary? Okay, this works. As the resets. Okay, so 400K. is decent. Do the same thing, but with like ridiculously. Do this, right? Oh, I know what happened. Yeah, I know what happened. Yeah, this is good. We do need to increase the speed. Hey, Boxen. What's the plan for today? You're catching the end of this, man. Been doing material science simulation work all day. You think we could go over papers? Sure. I'll jump in the Discord for a little bit. Are catching me at the end of a very long week, so we'll see how coherent I am. Do my best. This, jump voice. There we are. I am in voice. Hello. Let me fix the mics. Devices. Yeah, hang on. Say something?
1212. Roger, Roger.
Yeah, that's good. Alright. Cool. What papers you got?
Yeah, I've selected a few. I think there's like three of them that are very interesting. I'm not sure exactly how much you think you have time to go through, but yeah, I think
Okay.
three is probably yeah.
Link 'em.
Yeah, I'll link them in the Discord. The first one is this one. um, they've basically the issue they try to tackle is that mutual information skill discovery is easily
Where did you post
foolable.
it?
In the general in the Discord. Oh.
Because you're gonna throw me heavy math at the end of the stream at the end of a long week. Let's see what this
I,
is.
if
Okay.
if you can do it, that's completely okay. I
Okay, let me
understand. It's just
see. I'm gonna try. Let's see what this is. We have it's revised skill dis this thing here. I don't think that this thing fundamentally works, but I think it's a good auxiliary. So going.
what do you mind just elaborating a little bit on why you think this wouldn't work?
Well, I mean, this has just been something that's been done for a very long time, and none of the like no reward RL stuff has really done anything all that impressive. And let me. They named their algorithm LS. Is this entirely humanoids?
Yeah, so most of the papers are mostly focusing
Robotics.
on robotics. Yeah, because I guess this is where the main issues come from. So the main issues I found across all the papers that the x-axis is always in steps. I've never found a single paper where they bring on the time constraint, but
Welcome to academia. Okay, this is the thing. Let's
Hey, but yeah, I think they do. Um,
See here. It's the definition. Their code any good? Let's see. Know where the
so their code is in test. You can see the main and
code's in.
yeah. I mean, it's better than the last one I showed you.
Is this
And then
what is based on? Is this
the
CleanRL or what is it?
the main algorithm is in IoT. I'm not sure exactly what you're looking for, but the main algorithm logic is in IoT, and the main training logic is in test. But yeah, yeah, you have the LSD dot. You have the LSD Python file right in the IoT folder.
Definition. Is Z like the
So
one hop skill
Z
vector?
Z is the latent variable of this. It's the
Is it
skill.
like is it a
Yeah,
one hot?
yes, I think. Yeah, I think that is. Let me see, because in some of those papers they don't one hot it, but yeah, I think most of the paper is one hot.
Okay. Heck is
I mean, if I had to simplify it, the way I understood is that it's dia1n, but just with a Lipschitz constraint to make sure that, the skills aren't just easily distinguishable without highly different trajectories. That's the way I see it.
not understood. That is what you want. Is it worth it? Is what worth it? Oh, I only recommend that people who know that they want to do a general. Probably just link me all the papers. That will probably be more
Yeah,
effective.
yeah, sure, I could then. I'll link them to you, ranking them from what I think is interesting. Um, in the Discord, is it good for you?
Yep. Okay.
So that's, if you're interested in my take, it's basically like an
Isn't it
advanced
so
version.
funny how like literally every single one of these papers has, oh, the other methods do nothing and ours does everything.
Yeah, so one of the big issues I found is that most of them also have hard time um, reproducing the results of the previous ones. So I agree with you, it's a bit weird on that. Were you interested into Map Elite sort of stuff, or did you think it wasn't going anywhere?
So the issue with MapLeech is again that you're training separate policies. Right?
Because I found one that is kind of doing some sort of map edit stuff, but into latent space representation of the parameters or something. It seemed quite
MapLeech
interesting.
works very, very well in places, but you're training separate policies, so you're splitting your data horribly.
Hmm, I see.
You also have to define like the axes of variation.
The three, okay, so I just linked to you a last one, and those are to me the most interesting ones. Then all the others basically had big issues when I looked into it. Most of the time it was just highly specific domain knowledge input into the intrinsic reward somehow. So I just gave up on them.
Okay. Castive.
And there's one last one actually. That one I'm still a bit suspicious about whether or not they've put like a lot of domain knowledge into how they create the latent space of the state space, because they basically
Thing doesn't show. Thing only shows coverage on this one maze, right?
Ronak, I linked the papers in Discord, but I can link them in the chat also if you're
Great.
interested.
They're in Discord, discord.gg/puffer. The best. Suck. Good.
What you're looking at when you're going
I'm just trying to
through it like
see.
this?
I'm just trying to go through and see if what what results various different thing are good.
Okay.
This thing work.
The thing is basically the same guy. So
Yeah. Well, actually, this is kind of funny then, isn't it? Because two labs are basically the thing. This says they say that work. PSD, SD.
that should be CST the way they print it. Yes, I think so. Yeah, it's a different one. CST is another one, and I just linked it in the Discord right now.
This is follow-up 1. Hmm. Okay, isn't this the same thing? Hang on, this is the same thing as this. The direct follow-up.
Yeah, I think
Okay,
it
this
is.
is the direct
Basically,
follow-up.
so the
This
difference is they're basically doing the
um
same algorithm, but in latent space, in a different
this
metric space.
isn't this the same? They have this, and isn't it just summed over time, or is there a bigger difference? See, this is a sum over time.
Hmm.
Value. Yeah, this looks like a isn't this just a straight sum over time difference?
I think you're right, actually.
I think if you implement one of these, like these, you kind of get both of these.
Oh, yeah, yeah, totally, yeah.
I don't know if this is going to be slow if you do this or not, right? I think you can maybe make it not slow. I think you can kind of turn this into you might be able to turn this into a cum sum or something. I think you can do this as like a cumulative sum over a segment.
Yeah, so I think the big difference with us is that we won't have full trajectories for the entire episode, right?
Out
So
of
if I do this,
segments.
yeah,
Segments.
right. Yeah, exactly, right. But I think it's gonna be good enough. But we need to have long enough segments. If you put
Before.
too small, yeah, right. I agree. Because one of the things you said to me last time was also that you need to do something trajectory-wise, otherwise it's not
Yes.
meaningful enough. Um, and so the only way to, I thought about what you said that we couldn't differentiate through the states, and so I think most of those papers just work around this by building an intrinsic reward, right? It's just because you can't do that, then you have to force it somehow, and that's what they do, most of them.
What is this contrastive doing?
Which one is it?
Also, this actions on cybernetics.
Yeah, so those one, okay, yeah. So those ones are basically, to my understanding, they basically added an exploration term to the skill discovery reward. Do you know them?
Probably like the best known robotics, like robotics RL. Am I missing something, or is this one pretty easy? All this in LSD.
Yeah, I think they are very, very similar.
See, just add an encoder somewhere, right? Add like an extra little encoder, and then you just do this in the train step, right? In the train step, you have to do this extra loss thing.
Yeah,
Pretty
yeah.
much it. Is this a reward or is this differentiable? Hang on.
In LSD or are you in Metro, right? Yeah, Metro.
Is this a reward or is this differentiated through? I don't want the AI to summarize shit wrong.
To me, it's a reward.
You think this is a reward?
Let me see if I can find.
How do they train this component? Minimum, what's this temporal distance? Hang on.
I mean, to me, this is used as a reward for the policy, but then the discriminator is trained. Everything is differentiable. So for this one, it's trained through gradient descent.
Okay, so you just compute this thing then in the train loop, I think.
Yeah,
You compute it in the train loop before you compute, like, you have to compute
the,
this thing in the train loop to add to the reward before you do advantage.
yes, yeah.
Enjoy your studying journey. New follow currently learning. This is not me learning deep learning. Um, this is doing research, reinforcement learning, tougher. We're looking for things to pull in from other sub areas that have gotten a little bit of attention in the last few years. We do have resources for people learning deep, like just general deep learning, though. No, I've been doing deep learning since I was like 16. This is I mean, this is like obviously not an area that I spend a lot of time in this thing. If you are new, most of the stuff around here is RL, but check the X, same as the Twitch handle. We have guides for general ML and for RL.
To me, the way we would implement those is very, very similar to the way you would implement ION.
I think so, isn't it?
Um,
Like they're all kind of pretty similar.
yes.
I would just
The
branch
big issue.
3.0, hack it, and then, like the thing is, I think if I'm not wrong here, and I'm exhausted, like I've been, like it's been a long week, but I'm pretty damn sure that if you just set T to 1, you get LSD, don't you?
Hmm.
Uh, definitely
Yeah,
do
I
not
think you're
use
right.
TensorFlow, Spirit. Do not use TensorFlow. Use PyTorch. If you must use Jax, use Jax. But do not, under any circumstances, deal with TensorFlow bullshit. Jax is kind of a freaking mess, though. So I think generally PyTorch is the way to go if you don't have a huge amount of support on specifically Jax. Have a reason to do Jax. Yeah, it has a lot of backup by Google if you're at Google. If you're not at Google, then everything is in mess, and it's on you to figure it out.
Yes, so you basically think that those are
I can't
interesting
tell,
enough
man,
for.
if they're the same thing or not, because I don't know if the phi is defined differently. If phi is defined the same, they release code with this one?
Let me see.
Yes, they did.
Yeah, yeah. Sorry, man. I don't have all the details in hand. I've basically went through so many of them, but
Oh, they actually have a blog post as well.
the big issue I have with all of those ones is that they train first in the unsupervised way and then go down for downstream tasks. I don't think that's something that is
No,
efficient
we would
enough,
just
and that
mix the objectives.
yeah. So you would basically mix the rewards, right? So
Yes.
you would probably have like and I guess my intuition says that you would start to have most weight to the intrinsic rewards first, and then slowly have it decay and give more and more strength to the environment reward.
Yeah, hang on. Spirit, you don't need to read 500 pages of anything, like at all, to learn deep learning. Keras is kind of awful. Um, here, look. The advice I give to new people in ML, there's some advice on how to read papers, because you do have to read papers. Where's the ML section? Just have you done CS231N? Just like go take CS231N. It's online. All the course materials I believe are online. Watch the lectures by Carpathy. Um, be a dramatically better use of your time. Like it's maybe like a month's worth of full-time work. Um, and that will teach you at least like as much as the average AI engineer in Silicon Valley. You can't just read a book to learn. Like you need to actually do stuff interactively. Here, I'll link you the article because like my articles link you to everything else. Like these link you to all the resources. There's also general programming stuff in here, but there's a section at the bottom for ML. And then there's an RL specific one. The RL is my main area. Taking ML, yeah. So I mean, the deal, like my deal here, right? I'm a researcher. I finished my PhD at MIT like a little over a year ago. I'm working on very high performance reinforcement learning, open source tools, and we have a whole dev community around that. It's on Discord GG/puffer. Um, I don't typically do a lot of educational material, but because people ask me for it a bunch, I wrote a couple of guides, and people have told me they're very helpful. So they kind of link you to all of the best resources by everyone else, kind of aggregates everything in one place for you. I have more stuff for RL specific than ML, but like general ML, it's pretty much just a course, a few projects, and like getting decent at general programming. That and learning how to read papers, which I cover. Okay. Um, I need to like actually go through this paper as a thing to see if they did anything like obviously insane. Is there anything that you could direct me to that you were like not sure about?
Yeah, let me look at my notes.
Yeah, no worries, Spirit. I'm a little terse today. I'm a bit tired. It's been a long week. I've been doing reinforcement learning for material science all day on stream as well. Trying to.
Oh, how did that go?
Oh yeah, you didn't see that. So we got Pufferlib bound to lamps, which is this very commonly used material science sim. I got a couple DMs from material scientists like asking to chat about this as well, which is awesome. Um, we basically have a thing where we can steer atoms around, have them be simulated with lamps, and we have to like get the forces and stuff to be actually realistic. So that's next. And what we're gonna do is do stuff like specify like the heat dissipation or such that we want, and have the atoms learn to steer themselves into a configuration that achieves that behavior. And then
Mm.
obviously, if they do that right, you can look at the material, you can look at the final configuration, and say, okay, I need to make that material. Material science.
Quite insane that you were able to do that in just under a day, right?
Well, I'm not saying it's any good yet, but I do have it bound to the main sim. Material science is generally a broad area encompassing material discovery, highly computational, a lot of computational methods, experimental methods for discovering new materials and engineering materials with specific properties.
You asked me about suspicious stuff on
Yes,
the
anything like because I like
balancing state explorations.
this is a long paper. This is too much content for me to be able like go line by line and tell you like and find everything at the end of a long week. But if there's a specific area that you said I didn't know if this was legit or not the way they did this, I can definitely like look at that and spot check it for you. I skip programming. No. Can I do martial arts and skip learning how to hit people?
I mean, in LSD, I didn't find anything like highly suspicious, to be honest.
Okay. And did anything in
But if you tell me, so I think the idea of this, right, was for us to
cut out?
the stream actually uh, restart or something.
Hang on, it's dropping. Second, folks. Okay, I think we're done dropping frames. Be good. Feel the best. Thanks, Barrett. Are you there, Boxen?
Yeah, yeah, I'm
Not
still there. You
dropping.
hear
Yeah,
me?
I'm not dropping frames anymore. Seconds.
Okay, yeah. So if you agree with me, I think the idea was that we go through a couple of papers. If you think they're interesting enough, then I put some time in and try to implement them
Yeah.
with Buffer.
So
Um,
I
so
don't look like going by creds. Sergey's group though does generally do good stuff, and it looks to me like they have a continuous line of work. I believe they did Diane like several years ago as well, and it like they're like getting better every gen. And the nice thing is if you implement one, you've kind of implemented both. I don't think they're
yeah,
particularly complicated. I would like it if all these papers had more baselines against each other, because like I don't see any baselines on this thing. SD. Yeah, nobody else has like independent implementations of this thing. Um, or this one either CSD. They all have baselines on Diane and Dad's, and that's all I saw, unless I missed some. Get some more questions to answer quick. What do you do for undergrad and graduate? Undergrad at Stanford, computer science. Graduate at MIT. Yes, the department is huge. My specialty is multi-agent learning. Spells deep learning. Haven't read it. Spirit. I've never read any full textbooks. I've read like sections of textbooks. I've never read any full textbooks on AI or ML or anything. In my opinion, it's like it's good as a reference. It's not as a good way to. It's not a good way to learn though in general. You need to learn. You need to learn through experience. You need to actually do projects and see how stuff works. Especially in AI. AI is like a highly empirical field. But um, did I miss something, or does nobody have baselines on these? Like, are there no independent baselines on these, Oxen?
No, I think the most
Oh
common
wait,
ground is Taiwan, and then they're just missing some of them.
I see
Do
CSD, not CSD.
Yeah, CESD is a different one.
Yeah, so like they all have baselines. The only thing that's a little sketch is like some of them. Do they both have bad baselines? This one is the only one that has bad base. Yeah, so this one has a bad base. Like this one says that this is not that. Well, not
Mm.
even. Actually, no, it has it better than Diane, so this is still fine. This says that it's like a good chunk better than Diane, or else, and then this one says, hang on, they went by train curve. Well,
Yeah, the biggest sketchy thing I found across all of them is that they really focus on state exploration, which is great, but there's very little done about actual rewards and downstream tasks.
why didn't you join an AI lab? Because everybody's doing the same bloody thing, Ronaldo. Everybody's just doing LLMs. Like they've put 99% of the focus into one area. They're like completely missing out all this other stuff in RL. Like they're just obvious, hard, important problems across all industries that are not going to be solved with LLMs. Just nobody's doing it. No, I'm doing it. Yeah, actually, this is kind of a closer comparison, right? This would be
Mm.
worth looking at because these claim to have very similar results, right? Similar results. No, this one the results kind of suck on, don't they? This one has. Well, I don't actually know if this one sucks. At the very least, they don't show. Yeah, they
Now
don't really
the thing
show
is,
behaviors. They only
that
show
one
this
I
is
was
on there.
a bit suspicious because the result they show on so they benchmark against Taiwan, and it's the results seemed a bit lower than on the original paper. So
Let's say if we go through these two seem to show similar results, right? Like, look, this
mm,
is the same task. This, this, right?
yep.
This humanoid. Pick. You guys actually claim better results, I think. I don't know pixels. Okay, so we actually do have to look at the difference between these two because I think they're claiming quite similar results. I think generally the Metro one has better benchmarks and everything.
Mm-hmm.
Where's the dang kid? This whose group is this? Peter's Abeel. Wait, are these the same? Wait, these are the same authors.
Abid is not in this in is all of them, but the Xiaogong Park
Yeah, the
is
first
in
author is
every
the
one of
same.
them.
Okay,
Yes.
so if the first author is the same, then this is 2023. This is a follow up. Why did they
Yeah, the
not
most recent
benchmark
one
versus
is
their
in
own
France.
thing? Wait, what the hell? Why did they not benchmark versus their own paper? Like from before?
Good point.
This sketchy as hell.
I
Thanks
mean,
for
maybe
sharing.
there was a review or something.
Thanks, Ronaldo.
I mean, maybe I don't know who Seung Park is. Maybe he was the supervisor and didn't really got involved
That's not how that works.
in the pictures.
That's not how that works. The first author is the like main student on. It's the supervisor's the
Yeah.
last author.
Oh, okay.
So Peter Abiel is a prof at Berkeley. Sergey Levine's a prof at Berkeley. Very close labs, right next to each other. Oh, it is now, but yeah. So and the first like authors are always the
Okay, so then
professors
you're
or
yes, yes, then you're very right. Okay, so the first version of Metra was in 2023, and the first version of CSD was in the same year. So um, actually, Metra was like a couple of months older than CSD, so it still raises the question. Yeah, if you look at the first versions, the last versions of Metra is 2024, but the first one was
current
2023.
arc. Do they do two different at the same time topic and not compare to himself? Got so did thing. I guess where's the algorithm?
I mean, they cite in Metra, they cite CSD, so
Okay.
that's weird, right?
Is this? Am I wrong or is this like? Trying to see how this is actually computed.
I mean, to me, it's very similar, right?
Yeah, hang on, because it's a state based as well. Oh,
Oh,
wait,
you're
it's
looking at
X and Y.
no, you're looking at DST, right?
Oh wait,
Yeah, sorry, the stream
well
is a
this
bit
is still
lagging, so
here. It's still they don't show the computation. This is paint. What's this inverse? What's this inverse matrix?
sorry, I lost the stream, Joseph. I can't really see what's
Yes,
happening.
okay, hang on.
Yeah, you have it on page 5. Or the code, sorry.
Which paper is this? We're looking through a bunch of Sea Parks, um, like exploration slash diverse skill diverse. Okay, so this like basically it looks like like all this code has been building up on this for PhD. Um, okay, so actually these are both follow-ups to LSD. He did two separate follow-ups to the paper. Okay, I think we just need to understand the difference between the two because he has two very similar papers that are both follow-ups to him earlier paper.
Between CFC and Metro, yeah?
Yes. I think it's likely you're going to end up wanting to do all of these, and they're going to be very similar.
Yeah, if you're okay with that, I think it's probably also going to be better for you in terms of time. Like I might start implementing the LSD, then move on, try implement the
Okay,
two,
there was
and
one thing I
uh,
noticed.
uh-huh.
You're going to want to just this check the code for locomotion. says right here that the implementation of LSD in here is much better. So if you're gonna refer to that like the implement, this is the thing to start with. I'd use this one. This is like he basically tweaked his original and then added some new stuff, right? Added like
Okay.
these changes, and now it's the new algorithm. So it's the combination of these improvements plus the algorithmic changes. So I would look here,
Mhm.
like right here.
Yeah, your stream dropped again.
Stream dropping.
Not sure if it. I don't think it's me because I still hear you on Discord, but
I haven't dropped any frames
hmm.
before. Okay, well, I think that this is most likely the play. Now, pretty much all of these have some sort of state difference of encoders, right? Like encoder state difference thing. Um, what you're gonna want to do is, Diane, there's a Diane branch. Okay, it's kind of old, but you can
Yeah,
see it.
yeah, I looked at it a couple of weeks ago.
It has like the pufferl in here. Well,
It was the old one, so it's still demo. I think you still had the demo file, right?
yeah, but where's pufferl? Here? Okay, so this is yeah. I have all like the Diane stuff in here. If you look, I think the main thing is yeah. So the main thing with Diane is like the sampling from the sampling of the indices, computation of the loss. I think you have to. I think you have to do it in this train function though. I think you have to recompute it. Affect the advantage. But yeah, this is what I would start with. I'd start with probably like the simplest of them. You're gonna want an environment, by the way, that's just like good for this type of research. I would just hack
Convert
like
circle.
yeah, I'd either just like yeah do that and hack on that. You might even just have make an empty map one, modify that, make an empty map, and see if they can go in different directions or whatever.
Hmm.
How's the RLM? RLM. I'm not a. I'm not doing a master's. Um. Yeah, there's been a ton of progress doing material science today. Okay. Yeah, I think that it's like fairly likely that there will be something here. Um, the author of Diane actually.
I don't know, those eyes and batch, I think, for Diane.
Okay, who also is
Let me see.
1,000 late. So let's see. I think if one of those papers like actually replicates, then they probably all will. You know what I mean? It's the same author,
Yep.
like
Yep.
built off the same code base. So I think that what I would do is I would spend a little time just getting the basics of like these delta state metrics in and make sure that's right. Get like a super simple environment where just like policy has to go to a place, right? Or like even do the no reward version if you want. Like you should be able to train that in 30 seconds or less. So you should actually have a very, very quick iteration cycle on this. And if you've got time over the next few weeks to do that, then I can help you on the actual experimentation side once you have stuff. Just like basically port up my old Diane stuff and hack on that. That'll give you a basis for
Yeah.
this. But don't use Diane. Use at least like
Yeah.
MS Material
Okay.
Science. Yeah, Andrew. How old are you? 28. All right, cool. Um, yeah. Thanks for
Yeah.
dropping
Thank you.
by.
Oh,
And
oh, okay.
this will be very useful if you get this to work. I think this will unlock quite a bit of stuff.
Okay. Yeah, that's quite exciting. I might be a bit slow for the next 3 weeks because I'm gonna be on holiday, but yeah,
Okay. Well, thank you.
I'll get back to you as soon as I have something going on.
Sure.
Um,
If this works, this will be very, very good on the research side because like this will also help us with multi-agent self-play, something I have to start on quite soon. So,
mhm. Okay, well that's quite exciting then. Thank you very much for your help. That was
thank
very
you.
helpful. And good luck. Thanks.
Thanks. Bye. On. Okay. So, oh, we have quite a few people watching now at the moment. Hey, everyone. So the deal with this stream is I'm a researcher in reinforcement learning. I run Puffer AI, private lab. All our stuff's open source. We do ultra high performance reinforcement learning. We have a whole bunch of demos on our website. On load. That's just flipping a little bit. This one. We have a whole bunch of demos on the website. My internet just totally screwed. It shouldn't take that long to. Something's today. Something's definitely wrong. Oh yeah, there we go. Okay. Yeah, we do high performance reinforcement learning. So if you're interested in that, the Discord. Lots of dev going on. And definitely just that. Great. All right. Anyways, we were doing material science stuff before. I'm gonna take one last look at this stuff before I call it and go for dinner. Right. So I was having trouble getting this thing to run with more particles in bigger space. Fix this real quick. How's the atomic control worked? This is still very early, Andrew. Like, I got some basic stuff to run, but it's not really enforcing many of the real dynamics yet. What are the prerequisites for RL? I have a guide on that. These two guides collectively will tell you everything you need to know and link you to all the resources. The general programming and ML guide. There's the specialized RL guide. They're just on my X. So the result here should be that all the atoms steer towards this target. Oh, actually, there it goes. It's kind of working. I am both a condensed matter physicist and a machine learning R&D. Why the stream caught my attention. The paper about diversity. So that's totally different because that's like core reinforcement learning research. The thing I'm doing here, uh, this is so I've gotten lamps right, and I've hooked it up to pufferlib as a puffer env. So I can run reinforcement learning where the RL is steering all the atoms around. The idea is that we're going to be able to get them to steer themselves into a configuration that matches some high level property that we evaluate. Demis is done. Lex Friedman podcast again. Yeah, I really don't listen to too many podcasts. I probably should watch that one though. Interesting that this learns a bit and then it kind of gets stuck. Alright, this is actually learning. I mean, we'll see what the result of this looks like. This is a very bad reward signal as well. This is kind of just our initial test, so this should actually get better from here. See if it's stable or not. Condensed matter physics. Learning R. Yeah, MG, if you're around, like, Discord GG/puffers where we do all our research, and more than anything at the moment, we are interested in how we get reinforcement learning to advance other fields of science, particularly those that rely heavily on simulation. Article you mentioned learning C. Why is C in libraries? Okay, well, the fact that you bring up sklearn is enough evidence on its own to learn some low-level dev. Learning low-level dev, like, is going to just save you a lot of pain and suffering because, like, most what happens a lot of the time is researchers gimp themselves by like not being able to make anything fast because they just won't step out of Python. And they literally have no idea about anything whatsoever about performance because they literally don't understand anything about how the hardware works. So doing low level code both allows you to write stuff that is performant, but even if you don't do it super often, it allows you to have some idea of how fast your code should actually be to stop writing code that is literally less than 1% efficient. Like all the RL researchers are just, yeah, we just PyTorch everything for years and they have no idea about system stuff. And like RL, the entire field of RL was running 10,000 times too slow for a decade. That's what Puffer fixed. Okay. This is kind of decent. Wait, why are they in a line like this? Bizarro, isn't it? Mess up an observation. How are they in a line? This is clearly like a messed up observation or something, no? Doesn't look like it. Y, goal, Z. Yeah, they're not. Like, if you just want to be a scientist, then go ahead, but you'll never be a good engineer if you just do everything in Python. You'll just always write horrendous slow things. C is very, very easy, and the fact that people think that like low level stuff is hard, it's just myopia. Low level is very, very easy. In fact, I find it easier doing a lot of stuff now in C than I do in Python. Like I could not write something like this in Python because it would be slow. In some sense, you just write very simple code and it is fast. Obviously, you can optimize even more than that, get fancy. Like, you'll basically, everything is instantly 100 times faster. The neural nets aren't in C, by the way. Not the, I mean, the neural nets, like, our neural nets training is not in C. Not the point. Yeah, that means that they were trolling. Like here, you literally could not implement one of the, like, you couldn't implement some of our environments in Python. Like, if you go implement Neural MMO 3 in Python, you can spend years optimizing it and you'll just always be like orders of magnitude slower. I know because I did exactly this. Literally, the code is just effortlessly faster and simpler for many things. And if you just refuse to learn things because you think you can do everything high level and never touch anything closer to the, like, closer to the actual hardware, you're simply wrong. Doesn't mean you can't be a great scientist, but you'll never be a great engineer. So weird that they, like, they're gathered on a line like that is just odd. So I just don't like C++. I really just don't enjoy it. It's just easy for me. There are probably times when there are things that you want, but like for everything I do, C is just really simple. You don't have to deal with insane things. C is a very simple language, and if you keep it simple in C, you can just get a lot done very quickly. Couldn't get DQN to work. A DQN isn't really supposed to work. Bad algorithm on its own. Kind of does a few. Like, C, like, the thing is, Spirit, C is very easy. Like, it's not even like a huge thing, like, oh, I gotta go learn this and that. It's like, you understand the basics of memory allocation. What is a heap? What is a stack? That is about it. Like, just write very simple code. Things are fast. Just, it's an effort, it's an exercise in simplicity more than anything. Bizarre to me. Why is it doing this? 0, 1, 2. This should be fine. For some reason, it's like biasing in a line. This is incredibly odd to me. What about the security dimension of C? You're writing research code. Nobody cares about the security of your paper implementation. Or your like your training test suite, not deployed applications. Like if anything, you'll train the model in a sim, and then you'll deploy the model, not the sim. The list of problems you'd like to try RL with. Well, I think like initial applications in areas that having more people with experience would be useful, right? We want to do stuff in material discovery. We're doing some stuff in robotics. We've got drone things in progress. Help. We want to do a 6 degree of freedom arm. I haven't done it yet. I think we could do a standalone 6 degree of freedom arm very well. Um, there's stuff in biosciences that I want to get to eventually, but doing simulation for bio is generally much harder, is my understanding. There's probably stuff in other areas I haven't thought of, right? But it's pretty much any disciplines of science or engineering where simulation is very core. CUDA is interesting. Yes, and the cool thing about CUDA, right, is if you write low level C, like it takes you a day to be able to implement basic CUDA stuff. You literally just copy paste your C into CUDA and it runs. Because CUDA is just C that runs on the GPU, splits parallelism across dimensions that you specify. That's all it is. CUDA is not hard. It's a pain to debug sometimes. Not hard. This is just like a bad reward. Fun. There we are. This months. Well, it will take you months to learn C when you're new to programming, right? That's expected. You don't understand like when, but like, I could go pick up any new programming language, at least any reasonable programming language, in like a few days now. It's expected that it takes you a while when you're new to programming in general. Or new to low level. Either way. I've worked very hard, right? I've like these things do not come naturally or easily to me. Spent a lot of time programming. I spent a lot of time on AI research. This is reasonable now, right? Like, this is at least a good enough baseline here. You're steering atoms. Sticking to big tech is ML. Yeah, it takes time and work. These things are not simply intuitive. Okay, so let's put this in the Discord. I think this is good for now. This is a decent spot to. I'll push this so you guys can play with this if you're interested. All this stuff is open source immediately. Might have to mess with some stuff to compile a little bit. Let me at least fix that up a little bit. Cool. Oh, is this gonna fail to compile though? It probably is. Here, what I'll do for now. I'll put this like this so that it doesn't include this. You guys, if you want to play with this, you can just move the knot or whatever. Okay, so there you go. There is material science plus RL on the GitHub. Hopefully this is not broken anything. See if we have anybody complaining at me on the Discord. Like I broke anything. Okay, cool. I gotta go grab dinner. Sunday is my day off. So I will be back on Monday with more dev, most likely. A ton of things to work on. I got a new article to write. I've got a poster to prepare for RLC in a week or two. So if you're interested in all this work generally, all of my stuff is at puffer.ai. It's all open source. If you'd like to help me out for free, try the GitHub. It really helps. And if you want to get involved with development, go.gg/puffer. I've had dozens of brand new RL people get into the space through Puffer. We have a lot of material to help you along the way. Not that hard if you have a basic uh, engineering background, ideally a little bit of AI background. Other than that, you can follow me on X for more RL content, where all the articles are. Be back likely Monday. Thanks, folks.